Hello, we're going to do day 2 of 6.4 and we're going to talk about repeated linear factors. And then we will also talk about prime quadratic factors. So what this is introducing is if you have a denominator and you've factored it and you have this factor repeated so many times, then you're going to have to write the denominators as, well, I'll read it. The partial fraction decomposition must include a partial fraction with its own constant numerator for each power 1 to n of that linear factor. Okay, so we have x, but we have that to the power of 3. So you're going to have one denominator x, the next one x squared, and then finally x cubed. Here you have a x minus 1, and that's squared, so you're going to have one regular x minus 1, and then an x minus 1 squared. And this seems like a lot, and it can be, but it does work out eventually. And as you can see, you can go A, B, C, D, E, and so forth. So let's take a look at this problem here, this 3a. Let's factor the denominator. Looks like I can take out an x first, and then I'm left with x squared minus 2x plus 1. And if I try to factor that, it looks like I would have x minus 1 and x minus 1. So my factors here, I have an x, and then I have x minus 1, and that's squared. So my denominators on my partial fractions are going to be x minus 1, and x minus 1 squared, which means I have an a b, and a c. We'll go ahead and do this the same way. So remember, this is my denominator. So when I look at my a and I say, okay, what is my denominator missing to get to this one? Well, it's missing an x minus 1 squared. So when I multiply that, I'm going to multiply it by x minus 1 squared. The b is missing just one x minus 1 and one x, okay, because we want it to get to this denominator. So I'm going to multiply my b by an x and then by an x minus 1. My c is only missing an x, so I'll just multiply c to x. Now we can't get too crazy here. We have to be able to remember to FOIL this. So I'm going to go ahead and just kind of do some legwork with this algebra. I'm going to FOIL that. So I have x squared minus x, so minus 2x plus 1, which obviously would be this anyway. And then I'm going to go ahead and distribute that through. So I have bx squared and minus bx, and I have my plus cx. I'm going to distribute that a through, so I have ax squared minus 2ax plus a plus bx squared minus bx plus cx. I will group these, so my squareds are together, ax squared plus bx squared, and then my regular x's are together, which I have 3 of them now, so minus 2ax minus bx plus cx, And then I just have my a at the end, my constant. I will factor out an x squared here. And I'm left with a plus b. I will factor out an x. And I'm left with negative 2a minus b plus c. And then I have my plus a. I should probably bring down my numerator. Now, if you notice, there is no x squared term, okay? There is, but it's 0 times x squared, okay? You just can't see it. If there was a different one, we would set a plus b equal to whatever's being multiplied to the x squared. But right now, we're only able to set it equal to 0. So I will write a plus b has to equal 0. Then my x, 1 is being multiplied to x. So my negative 2a minus b plus c has to equal 1. And lastly, my a is my only constant, and that has to equal 2. Well, this is kind of nice. If a equals 2, then b has to be negative 2. And if a is 2 and b is negative 2, I'm going to fill this in. If a is 2 and b is negative 2, I have negative 4 plus 2 plus c equals 1. I have negative 2 plus c equals 1. So c must be 3. So I will just go right on back and I will put my 2 in for my a, my negative 2 in for my b, and my 3 in for my c. There we go. It's a little bit more work, but it's not too bad. We have another one here, and we'll do it pretty much the same way. So I will start by factoring the denominator. I'll take out an x. I'm left with x squared minus 6x plus 9. This I can rewrite as x minus 3 squared because it's x minus 3 times x minus 3. So that's my denominators here. I will have an x, I will have an x minus 3, and I will also have an x minus 3 squared. So A, B, C. Okay, so I'll write my numerator and I'll start multiplying it through. So my A is just missing an x minus 3 squared. So A, x minus 3 squared. My B is missing one of these and one of these. So my B is missing an x, and it's also missing an x minus 3. And my C is only missing an x. So similar to the other problem. I remember that, let's see, A, and this is x squared minus 6x plus 9. And this is bx squared. I keep pressing a weird button. Minus 3bx plus cx. Distribute that a through, so I have ax squared minus 6ax plus 9a. And I'll bring the rest down, plus bx squared minus 3bx plus cx. Ooh, that's me. You don't want to see that. I didn't even know you could do that. I was just trying to get to my purple. Okay. That's not purple. I wanted purple. We'll see. So I'm going to group my squareds. And then my x's, which is here, here, and here. Whoops, -3. And lastly, my constant of 9a. Factor out my x squared. Factor out an x. Whoops, 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 whoops. And then I have my constant. So, again, I don't have an x squared term. I said I don't, so why did I try to write it? So that means this needs to be set equal to 0. Wow, I'm really making that pretty awful. And I'm going to ignore it now. So, a plus b has to equal 0. Negative 6a minus 3b plus c has to equal 1. And 9a equals 18. So, a equals 2. If a equals 2, then b equals -2. And if a equals 2, so that's -12 plus 6. So I have -6 plus something equals 1, so c has to equal 7. So 2, -2, and 7. And I will go ahead and write those in. And that's my answer. Wow, that is whack. Okay, one last thing we're going to talk about is prime quadratic factors. So far we've only dealt with linear denominator factors. So now we're going to talk about when the denominator is a quadratic. And the difference with this is instead of just putting an a or just a b as a numerator, you're going to have to put something like bx plus c or dx plus e. So I will go ahead and kind of show you how to set this up, and then we'll go through it. Okay, so when I look at my denominators, we can't factor this down anymore. This is it. This is your prime quadratic factors. Okay, so what you have is an x squared plus 1, and then you also have an x squared plus 1 squared. Because remember, this is the same thing that we just did on the last slide. Okay? So you have to keep counting up till you get to the right power. Right? And then because it's quadratic on bottom, you're going to have to use ax plus b and then cx plus d. Okay, and this isn't too bad. Let me switch some colors around. So when I look at this one, well, first I guess I'll write down my numerator here, x cubed plus 2x. This is just missing one of these, okay, because we have to get to this. So I'm going to write ax plus b, and it has to be multiplied to one of these, x squared plus 1. Now I put parentheses around these because they're binomials. We will have to FOIL those in a second. This one here, we don't have to multiply this to anything because the denominator is already the full denominator. So I'm just going to write down cx plus d. So I'm going to go ahead and FOIL these two binomials. So I have ax cubed plus ax plus bx squared plus b. And then I'll bring down my cx and my d. And then I'll start grouping. So the only cubed one is ax cubed. The only squared one is bx squared. And then I have an ax and a cx. So if I factor out an x, I'd have a plus c. And then my constants are b and d. Looks like I'm ready to set this up. All right, my cubed term is a is equal to 1, so I will write that. My b x squared term, there is no x squared, so it's going to be equal to 0. So I'm going to set b equal to 0. My x term has to be 2, so a plus c equals 2. And then my b plus d has to equal 0 because there's no constant. Well, as fun as this is, I think these are kind of fun because you already know everything. If a is 1, then c has to be 1. If b is 0, then d has to be 0. So then we just fill in our a, fill in our b, fill in our c, fill in our d. So I'll take away my a, take away my b, take away my c, take away my d. My a is just a 1 plus 0. My c is a 1 plus 0. So I could just write this as x over x squared plus 1 plus x over x squared plus 1 squared. I really don't know why circling is such an issue on this thing. Let's do one more to make sure we got it. My denominators, my x squared plus x plus 1, like there's nothing I can do. So that is going to be my denominator, x squared plus x plus 1. And then my next one is going to be x squared plus x plus 1 squared. And I'll still, because it's a quadratic on bottom, I have to have ax plus b and cx plus d. I have a 4x cubed minus 7x. And I'm going to multiply my ax plus b. It's only missing one of these trinomials. So I'll write that out, ax plus b multiplied to x squared plus x plus 1. Oops, there we go. And then my cx plus d doesn't need to multiply to anything, so we'll just throw that on down there. I need to distribute this, which looks like a pain in the butt. So ax cubed plus ax squared plus ax plus bx squared plus bx plus b plus cx plus d. Good gosh, this is way neater on paper. I will group my cubes together. There's just this one. And my squareds together. So I'm going to factor out that x squared. And I'm left with a plus b. And then I have my, I'm just going to switch colors for my benefit. I have my ax, my bx, and my cx. So I'll factor out an x. And I'm left with a plus b plus c. And then my constants are just b and d. So let's set some of this equal to each other. So my cube term is multiplied to a, and this is 4, so I know a equals 4. My squared term, a plus b, there is no squared term, so a plus b has to equal 0. My x term, a plus b plus c, has to equal -7. And my constant b plus d, that is 0. So b plus d equals 0. So my a is 4. And my b has to be -4. If this is 4 and this is -4, then c has to be -7. And if b is -4, then d has to be +4. So we'll just go ahead and I will rewrite it right up here. So 4x plus 0, wait, b is -4, so 4x minus 4. So that was my a and my b, and that's over this. We'll write the denominator in here. And then my cx plus d, my c is -7, and my d is 4. So that's what that would look like. If I multiplied this through, I would get this. Let me know as you have questions. This is due on Friday, and have a good weekend then.